Hi, welcome to the GlassFish 3.1 launch webinar. I'm Anil Gaur, Vice President Software Development at Oracle. I'm leading the development of Java EE platform and GlassFish application server with the community. Today is a very exciting day for all of us in the community as we launch our latest and the greatest release ever, GlassFish 3.1. The main theme of this release is clustering and high availability, but there are several other new features throughout the release that would be beneficial for the developers and the community. This is the release where we marry Java EE 6 innovation with enterprise grade features. This is going to be the first Java EE 6 compatible application server that offers clustering and high availability. This is built on GlassFish v3 that we shipped in December 2009, which sits on the microkernel HK2, which enables us to dynamically initiate the services and start the containers so that you pay for only the services you're using. That way you save the system resources. The objective of this webinar is to give an insight into the features this release has to offer to you and how you can make the best out of it. For that, I have the subject matter experts with me, my team. There are two members that are not here in the room with me, so I will introduce them to you, and then the rest of the folks will introduce themselves. So Jerome Doche. Jerome is the main architect in GlassFish team. He's the guy behind HK2, and his fingerprints are all over the place in the GlassFish code. And then Tom Miller. Tom is an architect for admin infrastructure. He led the clustering implementation in 3.1, which happens to be the theme. And then I will let you guys introduce yourself.
I am Mahesh Kannan, and I am the implementation lead and architect of the replication module in GlassFish.
I'm Ludovic Champenois, the GlassFish tools architect, also in charge of the REST admin backend, which is used by the admin console and the Eclipse and NetBeans IDE.
Hi, I am Nazrul Islam. I am the engineering manager responsible for GlassFish 3.1 release.
My name is Chris Casso. I'm the technical lead for the 3.1 release of GlassFish.
So Nazrul, why don't we start with you, since you have been involved in this release since the beginning, you led it through the end, and I understand all the challenges you had to face throughout the release. So I would like you to give an overview of all the features in this release, and also what are various flavors of this release, what are the different bundles that people can choose from?
Sure, Anil. Let's take a look at the GlassFish 3.1 feature sets. GlassFish 3.1 is one of the most innovative modular application server out there today. The new clustering and high availability features for 3.1 release are built on top of the modular v3 kernel. The whole server is comprised of about 262 modules. The server is very intelligent about initializing its services dynamically when needed. This reduces the overall server footprint. You only pay for what you use. With GlassFish 3.1, one can start small initially with web profile and grow with their needs to full platform. GlassFish 3.1 release itself is built on extensible interfaces such that when additional runtime services are initialized, the associated management interfaces also get added. This makes GlassFish 3.1 an ideal platform for OEM type use cases. One of the goals of 3.1 release was to deliver a first-class development environment for our developers. As you know, GlassFish 3.1 supports Java EE 6. EE 6 advances the ease of development features introduced in Java EE 5, improving developer productivity. The heavy use of annotation in EE 6 results in more plain old Java objects and far less XML configuration, resulting in fewer developer artifacts to create, manage, and maintain. Based on our internal analysis, 3.1 release has improved startup, deploy, and redeploy cycle by about 29% on Windows over 3.0.1 release. The save session on redeploy feature now support stateful session mean and EJB timer. This helps developer test new code changes during redeploy without having to repopulate the session data. 3.1 continues to provide excellent support for NetBeans and Eclipse. Let's review the production-ready features of this release. 3.1 delivers credible enterprise feature sets. It provides optimized runtime performance for your production deployment. Based on our internal performance analysis and benchmarks, 3.1 provides 34% better HA performance over GlassFish 2.1.1 release. Your mileage may vary. We also added several features to make GlassFish 3.1 better suited for production deployment, such as integration with SSH for remote node management, advanced load balancing during failover, improved transaction recovery, and improved message queue clustering. The extensive support for clustering across the entire product provides production-grade reliability, scalability, and fault tolerance for the deployed applications. 3.1 supports a wide range of platforms, giving users a choice to deploy where it makes sense for them. 3.1 comes with advanced management and monitoring features. It continues to offer the easy-to-use centralized administration. The domain administration server is very scalable and can manage 100 instances. 3.1 also has comprehensive support for RESTful API for management and monitoring. The application versioning feature allows users to version their application during deployment. The application scope resources feature enables users to limit the scope of a resource to a deployed application. 3.1 also added improved JDBC monitoring and security features. These capabilities allows application clusters to be provisioned dynamically and/or upgrade, redeploy application to meet user demand without service interruption. There is a list of features that comes with Oracle GlassFish Server Control. Oracle GlassFish Server 3.1 offers interoperability with other Oracle products. Monitoring scripting client enables custom monitoring scripts using fine-grained probes. Domain administration, backup and recovery enables scheduled automatic backup of a live domain. Performance Tuner enables up to 300% performance improvements over out-of-the-box configuration, giving customers an innovative, performance-based, secure foundation for production deployment. Oracle GlassFish Server has two major distributions. The web profile is about 38 megabytes. The full platform is 58 megabytes. We also introduced a new distribution for load balancer plugin, which is 26 megabytes. For those of you who are interested in Java EE SDK, the web profile distribution is 43 megabytes and full platform is 65 megabytes. GlassFish 3.1 offers comprehensive upgrade support from previous versions. Existing 2.x users may install GlassFish 3.1 side by side and upgrade the configuration. 3.x users may do so in place using Update Center. Let's take a look at GlassFish installation. Here are a few resources for 3.1 release. I have downloaded the latest binary from glassfish.org. To install the zip distribution, simply unzip the GlassFish zip bundle and GlassFish will be installed in that location. After that, go to the bin directory and type in asadmin start domain to start the server. This takes a couple seconds, and after that it will tell you the log file location and console port. Console is running on port 4848, so let's take a look at that. Since this is the first time GlassFish had to initialize web container, GSF, and RESTful administration backend, it takes a couple seconds. Here we go. From the management console, one can manage the clusters and standalone instances. One can also manage the configuration. So let me go back to the administration server that I just started. I will stop it, and server is stopped successfully. We can also take a look at quickly at the installer distribution. To use that, simply use the bundle. Installer will appear in a couple seconds. I'm using the open source distribution here. Simply follow the installer screens. I'll pick typical installation directory. I'll also go with the default. I'll also install the update tool. Clicking install to install the software. This will install the binary at the specified location. We are hearing lots of praise from the early adopters on how much they really enjoy the fast startup time and easy to use centralized administration of GlassFish 3.1. So I encourage all our listeners to take a look. To summarize, Oracle GlassFish Server is the world's first implementation of Java EE6. It provides a flexible, lightweight, extensible, fully featured, production-ready Java EE application server. Back to you, Anil.
So Jerome, I would like you to share with us, what are some of the enhancements we have made in HK2. I believe HK2 is now shared by WebLogic Server, and we had to add certain new features for that. Or any other cool feature that you have added which will be relevant to the community.
Thank you, Anil. My name is Jerome Daucher. I'm the GlassFish architect, and I'm going to talk today about some of the improvements we've made to HK2 in the 3.1 release of GlassFish. So HK2 is basically our microkernel, and it provides a number of features for the GlassFish runtime. And the first feature that comes to mind, of course, is an isolation layer to the module management system. So basically, you can see the module management as OSGI, and we've got an isolation layer on top that allows us to be independent of the OSGI APIs. On top of that, GlassFish is basically architectured as a service-based architecture, around the service-based architecture. And that means that we needed a really strong framework for declaring services, consuming services, and that is something which is done in HK2 and basically done through annotations. Now, the way we consume those services can be explicitly through API lookups, but most of the time people rely on things like dependency injection, where they can use annotations like the @inject annotation to be able to inject services inside their code. So all of that is provided by HK2. On top, we've got also a configuration backend, which basically is an ability to load and save configuration files, usually XML files, and do that through very well-defined interfaces similar to JAX-B, if you know that technology, and that will allow us to have these configuration objects being present in the service registry alongside the normal services. So basically, you can inject elements coming either from a real service or from the configuration directly inside your code. And of course, we've got an mbins facility so that these configuration objects can be automatically promoted to the mbin server. And this is really a number of features which are aimed to help developing server-side software. It's not something which is linked to Java EE or to GlassFish, and that's why it's not only open source, but it's a separate project which is available on hk2.java.net, and that can be used for any server-side development. All right, so what did we add in the new release of HK2, which is present in the 3.1 release of GlassFish? So one of the biggest item we had to do when developing this new version was to add support for the WebLogic product. So HK2 is being used since version 3.0 in GlassFish, but it's going to be used also in the next version of WebLogic, and that's to improve the ability for the two products to share code, and certainly a number of features that HK2 was offering was interesting to the WebLogic team in any case. Nevertheless, there were features that we thought were missing, and the first one was the ability to have a startup facility coded inside the HK2 product. And that startup facility is basically the ability to define startup services, prioritize them, and have HK2 take care of starting them in the right order with very specific steps that can be verified and achieved through annotations. So I'll get into details, but basically this is a startup facility so that you do not have to write startup code. You just write a certain category of services called startup services, and those will be called in the right order with the right priorities. On top of that, because we've had these services available since version 3.0, we've added facilities to be able to track services. So basically it's a facility where you can get notified of changes of a particular service. You can also listen to service, and that's basically listening to the life cycle of that particular service, its allocation and its deallocation. And finally, to help with development and testing, we've added a JUnit integration. So let's look into all this in more detail. First, the run-level services. As I said, we needed a facility to mainstream the startup services and startup sequence of an application server. And basically, this is all coming down to a number of actions that need to be applied in the right order. And by defining startup services, we've been able to define those actions. And by using dependency injection plus a priority, we've been capable of ensuring a very specific ordering of these actions without having to manually go through each of them through code or having to have each action reference the next action and stuff like that. So each action is independent of each other, but because they have a particular run level or a particular priority, we are capable of ordering those and starting them in the right order. The next feature we've added to HK2 are the service listeners and trackers. This is the ability to register interest to a service creation and deallocation. It's pretty simple, and it's really great for cross-cutting concerns. So ability to know that particular service is being allocated without having the service to explicitly call you when that happens. And finally, the last thing we've added is a JUnit integration. So when you start talking about dependency injection and the ability to get your dependencies directly injected inside your fields or method calls, it becomes harder somehow to test, because obviously you don't have any kind of factory object you can go to request such objects anymore. So you can't do that through code, and it's more difficult to have access to your services and your dependencies if the unit testing facility is not providing you a dependency injection as well. So we've added this dependency injection facility to JUnit, and we do that through providing a special runner class. And you can see here a small example where you have a test which is injecting a particular service, and then it can use it within its method, this test method. So this feature makes it much easier and much more natural to test your code using injection, just like it would be in your living running system. So these are some of the features we've added in HK2. There is many more on top of obviously bug fixes and various improvements. If you are interested, please go to hk2.java.net and you will find more information on how you can use it or participate to the project. Thank you.
So moving over to Tom. Tom, unfortunately, is not here with us. He's at Nebraska. So Tom, as I understand, the clustering architecture has been much simplified in this release. Can you walk us through how to create a simple cluster and do the basic configuration?
Thanks, Anil. The clustering administration feature of GlassFish 3.1 consists of a command line and console interfaces for managing nodes, instances, and clusters. A node represents the software on a system that hosts instances. A node can be managed using either local commands, which require being logged into the node's host, or using centralized administration provided using SSH. This SSH capability replaces the concept of node agents from GlassFish 2. Instances, either clustered or standalone, can then be created on nodes. During this segment, I'm going to show you how GlassFish supports creating nodes, instances, and clusters, and how an application is deployed to a cluster. First, we need to set up SSH so that we can manage our nodes and instances centrally. The command line interface command for doing this is called setup SSH. This is essentially a front end for the keygen tool in setup SSH. The command prompts us for a password, which we enter, and then it creates key files and copies them over to the node that we want to manage. Next, we will install the GlassFish software on that node by using the install node command. We enter in the install dir and the name of the host, and it creates a zip file of the GlassFish software, copies it over to the host, unpacks it, and gets it all ready to run so that we can put nodes on that host. Now we're ready to start up the domain, which we do with the regular start domain command. That's the same as in GlassFish 3. And next we are ready to create a node. The create node command again takes the install dir that we used previously, and this time we specify the node host, which in this case is IDA S1009, and the name of the node, which is N1. Next, we create a cluster, C1, by using the create cluster command. And after that finishes executing, we will run a create instance command to create an instance within that cluster. The cluster option says which cluster it should be part of, and the node option says which node to create the command on, in this case N1, where we'll create an instance called I1. You can see here the ports that have been assigned for that node, that instance. Next, we'll create an instance on the local host. There's a built-in node called localhost-domain1 that can be used to create instances on the same host where the DAS is running. And so our create instance command that specifies that node does exactly that. Now we have created our instances, so we're ready to start the cluster. So the start cluster command just takes the name of the cluster, and it effectively runs the start instance command on each of the instances. So now we have our instances running, and we'll run list instances to see that they're working. So this shows us which host the instance is running on, the administration port for that host, its PID, and the state that it's running. Finally, we're ready to deploy an application. I've got a little Hello World application here. We'll specify the target as being cluster C1 and the name hello. And this command then copies the application out to the cluster, installing that application on each of the nodes. At this point, we can go to the web browser and see that the clusters are actually running. So here I've got my web browser, and I'll enter in the name of the host, which is IDA S10-9, and the port is 2880, which is where 2080 where the Hello application is installed. And there you can see that it's running. So let's also look at the host that instance that we had created on IDA S10-2, and we see that the application is running there as well. So we've got our two instances with two applications running on them. So let's look at the console and see how we can manage our nodes, instances, and clusters within the GlassFish console. So we'll be logged into the console by going to port 4848. And the first thing we want to do is see what cluster we've created. So we click on the clusters link, and that brings up a cluster page, and you can see we have cluster C1 and both instances are running. All looks good there. We can click on the cluster and get more information about it. It tells us what application, the Hello application, is deployed onto the cluster. and we see the instances. Now we can show how a new instance can be created using the console rather than the command line interface. So we enter in a cluster name, an instance name I3 on node N1, and this basically does the same thing as the create instance command did, except we're doing it through the console. Let's go ahead and start that instance. We just click on the instance name and click start, and that instance will be started up. Again, this is using SSH to go out to that node. Now let's make sure that that's really worked. So we go to host 9 again, port 28081, and we can see, yes, our application is indeed running. Okay, so let's go back to the cluster page, and we can show how we can manage the cluster from the console. So let's go ahead and stop the cluster. We select the cluster and click stop, and it'll go out and stop each of those instances that are in the cluster. So there we can see they're all stopped, and now we can go ahead and delete the cluster, and the console gives us the ability to delete a cluster and all the instances that are in it just with one step. So now we can see that that cluster is gone. We can go ahead and undeploy our application, and finally we can delete that node that we created at the beginning of this demonstration. Okay, so we've cleaned up after ourselves. Our node is deleted, the cluster is gone, and that shows how we can manage clusters from within GlassFish 3.1. Back to you, Anil.
So Mahesh, as our HA guy, HA architect, can you tell us, what are some of the new features in HA? I believe there's some performance enhancements in this release, and maybe you can walk us through some of the load balancing options and configuration.
Sure, Anil. I will talk about some of the new high availability feature that got introduced in GlassFish 3.1. Java EE applications typically have significant session data. If a server instance fails, all the sessions served by it will be lost. GlassFish Server provides high availability of HTTP and EJB states by replicating them to other clustered instances. Session state replication is provided by an OSGI module, which is loaded only when HA-enabled applications are deployed. This replication module distributes session state uniformly among instances. This is a significant change from GlassFish 2.1, where an instance will replicate the user sessions only to its neighboring instance. Replication module uses Group Management Service, which is also an OSGI module. GMS provides notifications about instances joining and leaving GlassFish cluster. These membership events are consumed by replication module to choose the appropriate replica instance to replicate a session. GMS itself has been modified to use Grizzly for performance transport. The replication module is used by Web Container for replicating HTTP and single sign-on sessions, and also by EJB Container for replicating stateful session beans. GlassFish 3.1 now additionally supports high availability of reliable messages and secure conversations in web services. This is a completely new feature that got introduced in GlassFish 3.1. Load balancers. We support Oracle iPlanet Web Server and Apache LB with ModJK. With Oracle GlassFish LB plugin, Oracle iPlanet Web Server has been optimized for better HA performance. Configuration of HA features remains the same as GlassFish 2.1. Let us see how the replication module in GlassFish 3.1 provides high availability of session states. For this, let us assume a 4-instance cluster setup front-ended by Oracle iPlanet Load Balancer. Let's say request 1 from user 1 arrives into the load balancer, and the load balancer routes the request to instance 1. Then the session 1 created in instance 1 could be replicated by the replication module to instance 4. Similarly, requests from user 2 could arrive into the load balancer, and if it happens to be routed to instance 1 again, the replication module will replicate the data to instance 2. The key point here is that the replication module does not replicate all the session data created in instance 1 to just its neighboring node. So let's see what happens when instance 1 fails. When instance 1 fails, Oracle iPlanet load balancer will route the request for user session 1 to instance 4. This is because that's where the replicated data resides. Similarly, request 2 data will be routed to instance 2. And then the session 2 data will be replicated to instance 4 or to instance 3. If we use Apache mod JK, and if the load balancer routes a request to, let's say, instance 3, then the replication module will pull the data from instance 4 into instance 3 and then replicate the data to either instance 4 or to instance 2. In terms of GlassFish 3.1 HA performance, our internal performance benchmarks show a performance improvement of around 34% compared to GlassFish 2.1. This is because of several new changes that we have made in both containers as well as in the replication module. For example, EJB and web session states that are created in a single request are all replicated to the same replica instance. Similarly, we have made some significant changes in batching of replication messages to reduce the network traffic. I am now going to demonstrate how to deploy and access a HA-enabled web application. For this, I'm going to use a 4-instance cluster with Oracle iPlanet load balancer. I'm not going to show how to create a cluster since Tom has already done an excellent job at it. To demonstrate the smart failover feature, I'm going to use Oracle GlassFish LB plugin. Let's start with the installation of the load balancer plugin. I have a VNC session already running on this machine, Proton 1, where we are going to run the Oracle iPlanet web server and the Oracle GlassFish LB plugin. I'm now going to log on to this Proton 1 machine. I have already installed the web server in this machine, and the load balancer plugin configurator is also downloaded here. I'm going to run the installer now, which will configure the load balancer with GlassFish plugin. This brings up the installer GUI. Let me move this. Click Next, choose the Oracle iPlanet web server, and choose the installation directory. And then specify the admin user ID and password. The host is this machine. So this will run the configurator. Shouldn't take a long time. Yes, it's done. Now we will run our HA application. I'm now going to deploy our web application. So I'm going to go to the DAS machine. So the command is ready to be run. We need to run asadmin deploy -- availability enabled equal to true. And then the application name. Now the application is deployed. We need to run one more script which tells the load balancer about our cluster configuration. I have a script already written for this. I'm just going to run the script now. Now we are ready to run our web application. I'm going to open up a browser and access our application now. and access and send the URL to the load balancer. This web application presents a form where we can add set of attributes that are kept in the HTTP session. So I'm going to add a couple of attributes. And as you can see, this request is served by instance 1. I'm now going to go and kill this instance 1 machine, and then we will access this application again. Okay, the instance 1 has been stopped. I'm going to come back to the browser and again make the request. And this time, as you could see, it is now served by instance 2 because instance 1 has failed. But as you could see, all the session attributes have been retained. That's it from me. Back to you, Anil.
So Ludo, first of all, I would like to thank you on behalf of all the developers as their representatives. So you have done a great job making sure we do not compromise on developer productivity or the ease of use while we added a bunch of these enterprise-y features. So that's great. Why don't you share with the audience, what are some of the new features with respect to developers and enhancements made in, various IDEs that we support?
Thanks, Anil. Yes, so GlassFish 3.1 comes with a very strong developer tool story. First of all, we are bundled with NetBeans 7, and you can download it from netbeans.org. Secondly, we have an Eclipse Update Center where you can download the GlassFish plugin from download Java, Net, GlassFish, Eclipse, Helios. Finally, Oracle OEP bundle that contains the Eclipse IDE plus WebLogic and GlassFish plugin, ADF, Oracle database. Is also available from the Oracle website. NetBeans and Eclipse integration with GlassFish share a lot of common features. For example, registering a local domain or remote domain for cloud development, secure domain. You can start, stop, debug, obviously, including remote domains. Manage servers via a nice runtime tab. Preserve session across redeployment, view local and remote files. We bundle the Java E6 documentation. You can register all type of GlassFish resources, JDBC, etc. And all IDEs provide very advanced wizards for JPA, JSF, JAX-RS, servlets, etc. You can also use Maven if you want, either with those IDEs or outside those IDEs. So it's very developer friendly and nightly build friendly. Let's start with the NetBeans 7 integration. So you can see in the runtime tab view the GlassFish 3.1 runtime registered. You can start it from there or look at the properties, enabling commit support, HTTP monitoring, JDBC driver deployment, using the preserve session across redeployment capability of the runtime, registering a Derby server. All those properties can be set from the IDE itself. So let's look at the pop-up menu. You can start from there if you want the server. So let's go and start it. And in a few seconds, the server will be up and running and the runtime tab view will be displayed. You can view the list of deployed apps, the list of JDBC resources deployed on the runtime server. And from there, you can also edit some properties. Let's move to the project view. Here we have a simple web application. So from this web application project, let's look at all the wizards NetBeans is offering you as a developer. So first of all, in the web category, you can create Java E6 artifacts like JSF, JSP, servlet, filters, all E6 ready, tag libraries, etc. For JSF, you can create JSF 2.0 web pages, manage beans, faces configuration, composite components, etc. Bean validation to add validation in your business application. CDI, creating beans.xml and manage beans directly from wizard. If you scroll down now, we'll see other wizards. persistence to create pure entity classes or entity classes from database, and from that you can create RESTful web services or JSF 2.0 pages if you want. So let's run this application from the IDE. Pop-up menu, run button. So the application will be deployed automatically, and NetBeans will show the web browser immediately. So let's click on the reload button on the browser, and you will see that this number is incremented by every time you click on reload. So it's the number of sessions is accessed by the client. So let's move back to the project view, open the servlet. So you can see two things. First of all, it's a E6 web servlet using annotation, no more web.xml. And we inject an EJB, which is defined in the same web application project as a servlet. So no more packaging nightmare. You can bundle your EJBs inside your web application. Let's activate this EJB by calling the business method called test EJB here. And we will just save this servlet, move back to the web viewer, and reload the application. And NetBeans has automatically redeployed this application. You can see the EJB used here. And the session has been preserved because now we access this page 4 times. Let's switch to the Eclipse integration with GlassFish. So here I see the runtime tab for the GlassFish runtime. So you can edit a few properties like preserve session, use real jar archive instead of exploded directory. Let's open the web project, view the servlet, so same as in NetBeans, inline Java E6 documentation for all the APIs. You can also view the APIs in the Java doc tab view here. Go back to server, and we will just click on the run button to start the server. Once it's started, you can view the runtime management tree where you can see all the deployed JDBC resources, for example JDBC samples, and see extra properties in the properties tab of the Eclipse IDE. Moving back to the project, we will select the project and click on the run button, which will deploy this web application to GlassFish. Eclipse will show the web page inside internal web browser. We can reload a few times this application, and as you see, the number of sessions is incremented. Let's edit this servlet. Activate the injected EJB inside this servlet. Reload, save, reload, and you will see that the EJB has been called. So here is a few links again to remember: netbeans.org and Eclipse 3.6 update center for Eclipse if you want. So check them out.
So in our commercial distribution of GlassFish, we offer certain value-added features which are available to customers who buy the support contract. And I have Chris here to give us an insight into what those features are and how they can solve the problem, take the pain out of that and reduce the risk in their deployments.
Thanks, Anil. As Anil mentioned, in our commercial distribution known as Oracle GlassFish Server, we offer additional features above and beyond what is available in the Community Edition. Similar to the Open Source Edition, Oracle GlassFish Server is available as both a full and web profile version. Premium support and patching is available along with a suite of tools and features that improves manageability in production deployments. The suite of tools is known as GlassFish Server Control and is bundled and integrated with Oracle GlassFish Server. GlassFish Server Control was formerly known as Sun GlassFish Enterprise Manager. It has some of the same features as Enterprise Manager along with some cool new stuff. I would like to highlight some important features that are part of GlassFish Server Control and then provide a short demo of a few of these features. Domain Backup and Recovery enables scheduled, automated backups of a live domain server. Next, the Performance Tuner can offer a huge performance improvement over the out-of-the-box configuration. You provide specific information about your deployment environment, and the tuner presents a list of recommended tuning parameters that can then be automatically applied. For improved monitoring, we have Monitoring Scripting Client, which enables custom monitoring scripts using fine-grained probes. Active Cache for GlassFish provides a high available, robust replacement for in-memory replication. Active Cache is provided through Coherence Web, and this feature will be available the first half of this year. Coherence is an Oracle product that provides data scalability, availability, reliability, and performance to in-memory session management and storage. You can find additional information about Coherence at oracle.com. Also included in GlassFish Server is integration with Oracle Access Manager, which enables single sign-on of applications and services. We also perform extensive interoperability testing of Oracle GlassFish Server with other Fusion middleware products. And finally, we offer a load balancer plugin for balancing load across cluster instances and smart failover on instance failure. So now let's jump to a few quick demos. The first feature I would like to demonstrate is the Monitoring Scripting Client. You can use Monitoring Scripting Client to write clients in the JavaScript programming language to provide monitoring data about Oracle GlassFish Server. While Monitoring Scripting Client is not new to 3.1, its support for clustering is. In v3, there were several administrative steps required to enable this feature. Those steps are no longer required in 3.1. So to begin, we have a 2-instance cluster set up and running on this host. So we have I1 and I2, which is instance 1 and instance 2, up and running. Let's enable monitoring for the HTTP service. By default, monitoring is disabled in the product. So we're targeting cluster 1, C1, and the module that we're enabling monitoring for is the HTTP service. I have created a simple JavaScript client to monitor when an HTTP request has been received by the web container. In the script, we are listening for the request start event, which is sent whenever an HTTP request has been received by the web container and is about to be dispatched. We can use the list probes ASAdmin subcommand to see the available probes. And in this case, I'm going to limit it to just the HTTP service probes. And there's just a couple, one for the end event, one for the start event. We can also get details on a specific probe. There's the details sub-option here, and we specify the specific probe, and we get a man page for that specific probe. So let's now run the monitoring script on the cluster. We use the run script subcommand for that. Again, targeting first the C1, our cluster, and we're going to use the JavaScript that we were just looking at. So that's now listening. And over here I'm going to do a wget. I'm going to ping one of our web services, or our HTTP service, listening on 28080 port. As you see on the other side here, the monitoring script went ahead and recorded that the start event occurred. And we can do that a couple times. We can also do the other instance, which is listening on 28081. That's our instance 2. We do that a couple times. So both instances have the probes activated. So as you can see, the listener in the JavaScript is invoked and prints a message each time the service is accessed. Combining the monitoring probes with JavaScript provides a powerful interface to tailor the monitoring of your GlassFish deployment to your specific needs. Another new feature included with Oracle GlassFish Control is scheduled automatic backups of the domain on a live server. So let's bring up the console. We'll go ahead and click on Domain. There's a new backup tab. In GlassFish v2, you can perform a manual backup when the domain was halted. Now you can schedule backups to be performed on a running domain. And you can configure this all through the console. I'm going to demonstrate this functionality on the console, but we also have subcommands in ASAdmin that can be used to perform similar operations. So clicking on the Backup tab, there are two subtabs, Backup Configurations, and there are none by default, and Schedules. And we deliver the product with 3 default schedules, daily, monthly, and weekly. In this case, let's create a new schedule. So let's do a twice-a-month schedule. Twice a month is what we'll call this. And let me just scroll this up a bit so we can see almost everything. We're going to change the day of the month from being all to the first of the month, and let's say the 16th. And let's set the hour to be 1 a.m. Okay, and then we can go ahead and save the schedule. So now we have twice a month schedule. Now right now the schedule by itself doesn't do anything, but we can associate it with a backup configuration. So let's go ahead and create a new backup configuration. And let's call this one, say, domain 1, and we'll do a full backup. We'll call it D1 full. And we'll go ahead and select that new schedule twice a month, and we have it enabled by default. And let's pick a location for the backups to be stored. In this case, we'll just use /temp as backups. And there's a recycle limit. So let's say we only want to keep 12 backups. When we hit the recycle limit, older backups will be deleted. And then this is going to be a full backup. We also support configuration-only backups. So we'll go ahead and save that configuration. So there we go. So now we have a full backup being performed twice a month on our domain. And we'll maintain 12 of those. So let's create another one. Let's do a configuration only. Maybe we want backup our configuration on a daily basis. So go ahead and call this one domain1-config. We'll use the daily schedule. We want this enabled by default. We'll also store the backups in the same location. So temp as backups. And in this case, we'll go ahead and keep 25. And we'll change this to be configuration only. We'll go ahead and save that. So what we have here now are two backups that have been enabled. One that's occurring daily that backs up only the configuration of the domain. The second one occurs twice a month, and this performs a full backup. They're both stored in the same location, and they have each have their own recycle limits, or in terms of when they will start deleting older backups. One's for configuration only, and one is for everything. So using the CLI, we can list some of the backups that were previously created. To do that, we use the list backups subcommand. In this case, we're specifying the backup dir as /temp das backups because that's where we configured the backups to be maintained. As you can see, we got backups for D1 config, which is our configuration only backups, as well as D1-full, which were full backups, which is essentially everything in the domain directory, both deployed apps and the configuration. To safely restore a domain, we should stop the domain, but in this case, I will restore the domain to an alternate directory I can point the DAS to later when I restart. So we use the restore domain command to restore domain. So we're going to, in this case, point to where our backups are stored, which is this temp DAS backups. We're specifying the specific backup config that we're using, in which case we're just going to restore the D1 config. I'm specifying an alternate domain directory because I don't want to overwrite the domain directory that I'm using in this domain, and the name of the domain that we're restoring, domain 1. So I go ahead and run that, and that restores that domain, or restores the domain bits into that directory. So Anil, that's a quick overview of the domain backup and recovery functionality available in the Oracle GlassFish server.
So before we close, I would like to take this opportunity to thank you all for your participation, contributions in the community. Last year was the year of change for us. We have gone through many challenges, but thanks to your trust, your support, we came out with flying colors, and the community has evolved much stronger. The next thing I would ask you guys to try out the product. You can see the URL on this screen, so you can download any flavor that you like. And also, I would like to give heads up that there are many other screencasts that we are planning that will cover each of these features in depth, and you can find information about the webinars at glassfish.org/webinars. So with that, thank you so much. And I would also like to thank all of you for being here with me and sharing this useful information with the community.